this could be a planted question. I have a famous, my diamond and whiskers plot. So I have a presentation about this. So, you know, science is predominantly worldwide done in teams, not by individuals. That's like the number one thing you realize. So you have to have teams, and they can be quite small teams. They can just be 2 of you. But sometimes they're quite big. And then I often think of this as a landscape, and I'm going to think about it. I'm going to draw it out here on the screen as if it's one-dimensional. Of course, it's multi-dimensional, but let's say it's one-dimensional. On one side, this side is wet and experimental, and this side is dry and computational. And I think of each person as having a diamond, and the center of the diamond is the area which they really are expertise at. That is their center, and then they tail off in both directions, towards the experiment and towards the computation. Then on those diamonds, I think there are whiskers, and the whiskers are what they can talk about. So they can talk about stuff which they can't do, but they know enough, they can talk about it. Now, my basic rule is inside of your team, you need to have your diamonds overlap. Your diamonds must overlap from the analysis through to the experiment. And the mistake in when you create a team is when there are gaps and the 2 whiskers overlap. So 2 people can talk about something, but neither of them can actually do it. And there's a couple of interesting things here. So the first thing is that there are plenty of skills over on the wet or experimental side, which are just hard-won, tricky, complicated skills. Be it, you know, how do you run an at-scale MRI facility? I mean, it's not so easy, basically. And anybody who thinks it is kidding themselves. Similarly, if you want to keep, you know, 400 Medaka fish, you know, you'll be amazed how complicated and fiddly it is. And then if you go all the way over to the dry side, the dry side is sort of, I feel, is often infinite. So I'm definitely someone who sort of started more middle and then drifted drier and drier, but slowly discovered that there were people who were much more sophisticated at me at statistics and computation. And then even when I talked to them and I said, you know, kind of, you're pretty amazing, was my basic thought, you know, what's it like being a pure mathematician? And I remember Peter Bickel, who's an amazing statistician, won the COPS medal. And he said to me, I'm not a pure mathematician. I'm a very applied mathematician. I'm almost a biologist. I was like, you are not a biologist. You are a statistician. And you know, beyond Peter, there was pure maths, which was like somewhere so far here. So I think this kind of diamonds and whiskers and the whole team is quite a nice analogy of how you build your team. And then also for students, in many ways, what you're doing as a student, I think, is trying to work out where the center of your diamond is. And something you have to realize as a scientist is your diamond will not go from the left side of the screen to the right-hand side of the screen. No one does that. No, it's just not possible. You might have whiskers that go that far, but you will not have your whole diamond across that. So you need to know where your diamond's centered, and you need to kind of stretch your diamond and fatten, deepen your diamond. But you have to accept, scientists have to accept that their expertise ends at some point. And then the right thing is not trying to fake it. It is to go off and find someone who can do that other part and, you know, work with them. And you know, there's all sorts of ways of doing that.